Uh,
All right. Greetings, wonderful people. Let's get started. So by the end of this section, you will be able to identify if a given relation is a function or not, find the domain and range of a function, rewrite a function in function notation, or rewrite it in function notation, and evaluate functions with given inputs. So we're starting a new chapter. It's a little bit longer, I think. It took a I wasn't really timing it, but we'll see how it goes. So what do we need to know? The set of ordered pairs can be shown in a table, a mapping diagram, graph, or expressed as an equation. So those are the 4 different ways that you can kind of show a relation. Now there are 4 ways, but these are all really the same thing. So like when you see one, literally it's talking about all of them. So I think there's a bit of confusion with some students when, you know, they'll see a graph or a map or a table or something, and for some reason they always seem to think that, you know, they're different things, but not always. A lot of times they are the same thing, just in different ways of showing you this information. So I know that's confusing, but the sooner you can kind of understand that these things are all kind of related to each other and they can all be used to describe the same set of information, you know, it's going to be a little bit easier for you. So some other things we need to know are the set of X values is called the domain, and the set of Y values is called the range. So those might sound familiar to you. Domain is X, range is Y, keeping it simple. All right, so this next one might be a little bit new, but a relation with distinct points is called discrete. So discrete, kind of to give you the quick rundown, if you think of a dice, it's usually a cube with 6 sides and they have numbers on each side, 1 through 6. A discrete set cannot have, like, you know, 3.5. You cannot roll a 3.5 with a regular dice. So that would actually be discrete. I can only pick those numbers 1 through 6. I can't pick anything in between or anything else. All right, and the opposite of that would be a relation with connected lines or curves is called continuous. So this is kind of like temperature, okay? So like you could have something that's 72.3 degrees. You could have something that's 74.5 degrees. You know, there's anywhere you can pick as sensitive as you can get your tool, your thermometer. You could probably get anything. So just any number can be picked, and any increment of that number can be picked. All right, so that's like a quick rundown. I'll come back with some more examples on some of those later. So more stuff that you need to know. A function. Now, a function is a little bit different than a relation, because to be a function, it's a little bit more strict. A few more things have to happen in order for it to be a function. Now, just because something is not a function does not mean it's not a relation. So keep that in mind. Again, the rules for being a function. So again, a relation is a function which each element of the domain is paired with exactly one element of the range. Okay, so that's a little, that can be a little confusing on how that works out. But I'm gonna keep it kind of simple, and that basically just means X values cannot repeat. All right, if an X value repeats itself, it is not a function. So here I have 2 sets of data, 2 sets of ordered pairs with 4 each in them. So this wavy bracket, the brace, means set. So that means that these are all 4 of them in a set together. So here I have 0, 1, -5, 2, 6, -2, and 5, 7. So these are my 4 spots. Now this one is a function. And if we look at all of the X values, 0, -5, 6, and 5, those are all of my X values. None of them repeat themselves. So that means this is a function. When is something not a function? Well, okay, let's look at the X values. And remember, for this one, we're looking specifically at the X values. So -7, 6, 6, -3. So in this case here, there was a little bit of an error, and that is we have 2 repeats of 6. And that means that it's not a function. So a function cannot have its x values repeat themselves. And I can explain this a little bit more, but that's for now, that's what you need to know, that x values cannot repeat themselves. And that's how you would use to determine whether it's a function or not, depending on the points that you're given, the ordered pairs. What about if it's something like this? Like this is continuous. So you see that this line has no holes or gaps in it. It's all just one line, and you can pick any value on this line, like say 2.5 or 4.5 or 5.1 or something like that. You can pick pretty much anything on this line. So vertical line test, in order to be a function, a vertical line cannot pass through more than one point in the relation. So here I have a function, and it's a linear function. So if you were in algebra 1, this would probably all make sense to you because it's just y equals mx plus b kind of stuff. But as I'm passing this line and I'm going left to right, so as I'm going left to right, working my way towards the right, you can see there's an intersection where it crosses or where it touches. And this line does not intersect any more than one time. See, you can kind of see the intersection going, as I go to the right, it goes up. But it does not cross any more than one time. That's all that's all we get, is just one intersection. So that is a function. None of the x values repeat themselves. The rule is still the same, but this is just a more visual way of checking it. So let's look at this one here. So I have this one, which is not a function. It is a sideways parabola. Actually, it would be a root. I think it's a root function. But anyway, so far right here, no problem. That's fine. Okay, that can happen. But as if I go any more to the right, I end up with 2 intersections, one kind of lower and one higher than the other. This is not a function because it's contacting more than one spot. So I'm going to just leave it here. Let's say 2. And to kind of explain why it's not a function, if we have an x value, we have 2 outputs. We have one here and one there. We have 2 values for y. So like if I go over, I'll just say it's 3. I don't know if it's actually 3, but it looks like 3. If I go over 3 up 4, then I run into one y value. The y value is 4, but I can also get a y value of, in this case, it looks like -3 or -4. But the x value in that case would repeat itself. So no, it's not a function. Now be careful, because just because something is not a function doesn't mean it isn't a relation. So these are both, all 4 of these examples are all still relations, but they are not functions. And again, a function is a little bit more strict. I'll have some examples in a later one that kind of goes into more depth of why it is a function or not a function. But again, for now, all you need to know is x values cannot repeat themselves. So let's go ahead and practice getting the domain and range from some of these values that I have here. So this first one here, for the domain, all I'm going to do is look at the x values, because again, that's what domain means. Domain is the sideways, your x values. Now, for the domain and range, let's put them in numerical order. So I'm going to open with a brace, because this is a set. So it would read as the domain is the set. And I'm going to start, let's see, with my lowest number, which looks like -1. And work my way up. So the next one is going to be 0, and then 4, and then 6. And those are my x values, -1, 0, 4, 6. Okay, let's do the range now. So range is the y value. So let's look at my y values. I have -9, -5, 3, -2. So those are the 4 numbers that I have. So let's go ahead and start with -9, -5, -2, and lastly, it looks like we have 3. Now make sure you're looking at the y values in this case. Double check it, make sure that I didn't repeat any of these, or maybe I swapped out one x for a y value or something like that. But anyway, Now we have to answer the question of, is this a function or not? So I have 4 ordered pairs, and I have 4 elements in my domain. That means pieces. I have 4 numbers in my domain. So since there's 4 pairs and 4 domains, that means that none of them repeated themselves. So this is indeed a function. So we're going to go ahead and put yes in there, that it is a function. And that's pretty much what, that's all there really is to it. That's all we need to do. All right, so let's do the same thing for this one. So start with the domain, and let's look at our numbers. So we have 5, -3, 5, and 8. So again, start with our lowest number. And it's always good to put them in numerical order because, well, in this case, we can see that there are 2 of them. Oh, now I only wrote 1, 5. You're probably already noticing that because it's the same number. You know, I don't need to put 2 things in there that are the same thing. So you're probably wondering why it doesn't look like this. Because, well, 5 is already used. We don't need 2 numbers with 5 in them. So these are the only 3 numbers that we can use for our domain. Now you can probably already tell something's happening because, well, one of the numbers repeated themselves, but let's go ahead and keep going. So I have the range here. So start with our lowest number. So look through all of your y values and just sort of work your way up. So -6, 0, and then 2, then 4. There we go. Now you can see that there are only 3 elements in our domain. So this says domain is equal to the set of -3, 5, and 8. Since we're missing one, that means one of them repeated themselves. So in this case, 5 has repeated itself. So that makes this not a function. So because of that repeat, it's not a function. All right, so domain for this one here. So my domain are the x values. Now, these are in ordered pairs. Right here we have a map. I'm sorry, this is a table. The next one's actually going to be a map, but this one's going to be a table. So it's kind of like a chart. So I have all my x values in this column here, and then all my y values in the next column over. And let's see, we're going to have to put this in. We don't really need to worry about the order so much. Okay, so with this one here, let's just do the same thing. Start with the lowest value and then work our way up. So in this case here, starting from the bottom, -4, 0, 2, 7. And these are ordered pairs also. Okay, so I don't know if it would really be a big help, but it'd be a lot of extra writing. But the ordered pairs would look something like this. And I'm only going to do a few of them. And that next one would be 2, 3. And so on. The next ordered pair would be 0, -1. But it does relate. So it's the same thing. It's pretty much the same thing as this top examples that we worked on right here. So anyway, let's go ahead and work with the range. So looking at my x values, the lowest one is -8, then -1, and then 3. And it looks like there's been a repeat of 3. So is this a function or not a function? Think about it. The answer is no, not a function. Wait a minute, or is it? Because remember, the rule is x values cannot repeat. But if y values do it, it's okay. Y values can do what they want. They can repeat themselves all they want, and it will still be a function. So that makes this one, yes, a function. All right, so that's it for that one. Let's go ahead and move on to the next one. Keep things moving. Like I kind of said, this is a bit of a long lesson. I don't know why. It just feels like there's been a lot of long lessons lately, unless, of course, maybe I'm just going a little bit slower through these than I normally would. Because when you're in an in-person class, I think things can move a little bit faster. But, you know, if you're looking at your computer and looking up and down, and then I have to type things instead of writing on a board, just takes a little bit longer, I guess. And this one's kind of an easy one because it looks like both value sets of x and y are already in order. Looking at our x column, nothing repeats. So this is a function. So yes, it is a function. Yeah, so this one, it's not like a very tough lesson. It's just kind of a lot of stuff to go through. All right, so getting ready to go to the next one. Same thing, we're still looking for the domain and range and then determining whether it is a function or not. So in this case here, we have a mapping diagram. It's very similar to a table in that we have column, that means up and down, row of numbers for both X and Y. But in this case here, instead of an ordered pair being written right next to each other, we have these lines. So sometimes it looks a little confusing. So I'm going to go ahead and write what it kind of means. So here I have -4, 0 as my first ordered pair. And you can just go down the line with the arrows. So with this case here, I would say, if it helps you to write all this stuff out, go ahead and write it out. And then the third line from the top, so that's 5, 2, 7. And then I have a last one of 5, 2, 9. So these are my 4 ordered pairs as I write them out. So if you want to, you can go ahead and write them out like this. You don't really need to, because here you can easily see all your X values. So -4, -2, I said -2, and then 5. So those are the 3 numbers that we have, because it's all there in the mapping. That circle only has 3 of those. And then for the range, we have 0. Oops, you need to put it in set notation. So 3, then 7, then 9. Oops, there you go. And these are already in order, actually. So mapping diagrams are always written from least to greatest, so the lowest on top to the greatest on the bottom. So you might notice that in some of these cases, you have these lines pointing basically across each other because the numbers are supposed to be written in order from least to greatest in both columns. So when I write it out as an ordered pair, you can easily see that this 5 repeats itself. And we are also missing one element from the domain. This means that it's been repeated and we don't need to write it twice in there. So I don't need to put 5 in there twice. And we also can see that there are 2 lines pointing to X. So X is being shared between 5, 7 and 5, 9. So that means this is not a function. So X values cannot be shared. They cannot be repeated or anything else like that. So they can only happen once. So this one, not a function. All right, and like I said, this one might look a little confusing at first because all these lines are kind of going off in their own direction and not really having any pattern on how they cross or anything like that. And again, you can do the same thing with this one and put them in ordered pairs, starting with lines like going down and up and stuff like that. Now with the mapping diagram, you can already see that there is one less number here. So one number is being shared, but I'll get to that right after I get done writing this. So just list our X values, and now we have to list our Y values. And again, it's already in order, so I don't need to worry about rearranging them to be in order. So it's all there. So in this case here, we can see that one of the Y values is shared. So this is the ordered pair 2 and 7 and 17 and 7. So is this a function or not? Answer is yes, it is a function. Again, Y values can repeat. X values cannot repeat. So since we have 2 and 17 as different X values, it doesn't really matter what the Y does. Okay, Y's are just sort of, they're a little bit more free to do what they want than the X values. And like I said, that's the only thing you have to worry about for now. So let's go ahead and move on. These ones are going to be graphs. So I have 2 graphs here. So we talked a little bit about discrete and continuous. So this is an example of a discrete graph because there are only certain numbers I can pick for X. Now, if I were to grab my vertical line, and move it around. So in this case, I'm going to start with since we're working with the domain, I'm going to start with the lowest, which is the negative side, the left side, and work my way up. So here I end up with my first number in the domain, and that would be -3. So I'm looking at the x values. Now in this case here, we can already see that one of them is being shared because I have a point up here and down here. So we have two crossings. So already this one has failed the vertical line test. Remember that vertical line test is a way to tell whether something is a function or not. And this one fails because we have two values right on top and below each other. Now, we already know it's not a function, so let's just go ahead and continue with our domain. So I'm going to go ahead and grab our vertical line and move it to the next point. So here we have another one. And remember, we're looking at x values. So just sort of like a number line, 0 is in the middle. To the right, positive 1, 2, 3, 4, 5. To the left, negatives 1, 2, 3, 4, and 5. So the next one is going to be 0. Oops. And then if I go more over here, so I'd pick up the line, but then I'd have to retype what I'm working on. And the next one here is at 2. So if I look at the number line right here, 1, 2, so it's 2, then 3, then 4, and there's one right below the 4. So I'm going to go ahead and mark that as one of our domains. And there you go. So now we have our 4 pieces of domain. Well, actually there's 5 points, but one of them has been repeated. So we already know this is not a function. All right, so now we got to get the range values. Now, I could draw a line and kind of move it, but in most cases, you're not going to be able to draw a line on your worksheet. So we're just going to kind of use our imaginations. Start from the bottom and imagine a line kind of working its way up. So we start with the lowest point that we have here, which is going to be -5, way down here. And remember, we're looking at the y values only. As I go up, I reach my next y value, which again, this one is 0 in the middle. Then it counts up 1, 2, 3, 4, 5. And then as we go down, it counts -1, -2, -3, -4, -5. So this next one here is at -2. Okay, and then go back to the line, go up, and then I see another one, and then it's right to the right side, and that would be -1. So again, we're looking at the up and down number line. Okay, and then continue. So go up to 1, and then continue up. So we get to 4. Now we have 5 numbers in our range. So 5 numbers in our range means that well, we already know it's not a function. We know we had one of the x values repeat, and we were able to know before we listed the domain and range because we checked it for the vertical line test and it failed. Because again, you cannot have it cross more than 2 spots. Now again, this is discrete because these are the only numbers I can pick. If I picked a number like say -2.5, I can't pick -2.5 because I have no dots at -2.5. I cannot pick like -1.3 because there's no dots there. I cannot pick +3 because there are no dots there either. So discrete means I can only pick these numbers. Whereas if I have something like this, continuous, no holes or gaps in this line, I can pretty much always have my vertical line cross the function. And it only has one point of intersection, only one crossing area, one point where they touch. So this is, yes, it is a function because it doesn't cross any more than once. Now, how do we list the domain? Because, well, it's continuous. We can't name all of the numbers. So we can't just say -1, -2, -3, -4, -5, or anything like that. Or, 1, 2, 3, 4, 5, or list all the numbers in order from there because, well, we can pick 2.2. We can pick 5.1. We can pick all those numbers. We can pick decimals. If we really, really wanted to, we could probably pick something like 3.4 something, 49, 41. We can pick any number in that. So that includes all of the decimals between the numbers too. So how do we write the domain? Well, these numbers go on and on forever. So if I go to the negative, that line goes on forever in the negative direction. It goes on forever, negative and down. This side goes on to the right forever, to the right and up. Now it should be all real numbers, but I'm going to go ahead and shorten this to just all reals. Okay, so all real numbers, all numbers that you can think of. So remember, real numbers are things like fractions, decimals, even numbers like irrational numbers, like roots of things and pi. Now I also said that this line goes down forever in both directions and up forever in both directions. So like if I go up to, up 50, I'd have to go over this way, maybe 51, but I would still have a crossing in the line. If I went down to negative 100, yeah, it'd be a long way, but I'd be able to reach this line here at some point, and I'd be able to get an X and a Y graph, an X and a Y coordinate from that line. So there's nothing we can't pick. So this one is also all real numbers. All right, so that's it for the graphs. And again, the continuous ones are a little bit different because you can't just name, you just can't name all the points and call it a day. You're gonna have to be a little bit more creative in how you get this, get them listed. Okay. Now moving on to another set of graphs here. These ones are a little bit weirder because you probably haven't seen anything like this, or if you have, you probably didn't talk about it all that much. Now we still have a vertical line. So to get the domain, start with your lowest numbers, and I have nothing, 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 until I get to about there. Then I have one point of intersection. But starting from the lowest thing, so this is kind of like interval notation. We start with the lowest possible number we can think of. Well, in this case, the lowest possible number that we actually have things at. So it's kind of like an inequality because in this case, my X values don't start until we get to -4. So X values that are greater than -4 is how we would write that. So if you think about it like, well, okay, so we know what the number line is, right? You have the number line on the bottom, and then you got negative numbers this way and positive numbers that way. So it's the same thing. But with this one here, there's also an up and down dimension as well. So it's two-dimensional, goes up and down and side to side. But it's still kind of the same thing. So I have a circle. Well, actually, in this case, it'd probably be a closed circle, and it would be pointing that way. So I would be able to pick anything greater than 4 for X values. So like if I had an X value of 4, my output, I'm sorry, my Y value would be, let's see, -4, -1. But let's say I pick another number, let's say -3. So I'm gonna move my line over to -3. And this doesn't really work out because I have 2 numbers now. I have 2 different possible numbers for Y. I could either get, that looks like 2.5, and down here looks like 1.5. Now it's probably not exactly those numbers, but I think it would be close enough to just say positive 2.5 and negative 1.5, although that's probably more like negative 1.4 or something. But anyway, yeah, you use the same things as you would do for an inequality. And this goes on forever. Now that line up top goes on forever. So even though I don't see it on the graph, anything keeps going, both sides, both arrows keep going forever. So I guess we're gonna have to work on the range now. And we already used the vertical line test. So in this case, it's gonna be a no. It's not gonna work. Because both of these rays are coplanar. They're both on the same graph. And they're not lines because lines go forever in both directions. These are rays because they start from one point and just sort of go out from there like a clock hand or something. Don't worry about that vocabulary, just some geometry stuff. Anyway, let's go ahead and work on the range. So if I start from the lowest possible number I can get, what is the lowest possible number? Well, if you can see, that arrow is pointing down forever. So actually it would be negative infinity. And if I look up, if I keep going up, up, imagine the highest number, that arrow is pointing straight up. So that means that it's going to go on and on forever in the up direction to positive infinity. So if that happens again, you just go with all real numbers. And there we go. That's it. With that one, let's go ahead and move on to number 10. So with number 10, this one's a bit of a tricky one because it's not really a circle. It's more like an oval, an ellipsis, because it's not exactly the same, measured side to side as it is top to bottom. So let's go ahead and work with our domain and see if it's a function or not. Remember, x values cannot repeat, so nothing on the function yet. When I get to here, then I reach the function. So that is the lowest number we have for the domain. So we can pick x values greater than -2. So -2 is the lowest number we can pick, but don't write this just yet because we still have another thing, because this domain actually is limited in both directions. So we can't just say x has to be greater than -2, because if we keep going with our vertical line, we reach a high point, another number that we can get. So x has to be also less than 5. Or less than or equal to 5, but we're not going to worry about that just yet. So if I write it down, I have x less than 5. Now what I need to do is take this and put it here so that I end up with a between statement. So just like when we were working with the inequalities and interval notation, this is going to be a between statement. So what I'm going to have to do is I'm going to take that x is greater than -2 and flip it all the way around. So let's go ahead and do that. So I'm going to put -2, and remember the mouth is open towards the x. So when I flip it, the mouth will still be open towards the x. So again, I just reversed that, and I'm going to move it down here to about right there, and then boom, we're done. So x is greater than -2 or equal to, and is less than or equal to 5. So again, we end up with a between statement there. X is between -2 and 5. So that's how we got our domain for that one. Now, the same thing is going to happen with the range as well. We know we're going to end up with another between statement. So I'm going to just write this one a little bit more. So again, imagine a line coming from the bottom to pick our lowest value, which is -2. But our y value has to be bigger than -2. So I'm going to go ahead and just write this one all together. And we also move that line up, 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 up till we get to 4. So y is also going to be less than 4. So the y values for the range are between -2 and 4. And is this a function? The answer for this one is going to be no. Okay, so not a function because it failed the vertical line test. And when we were counting the domain, you'll notice that anywhere from here to here is going to cause 2 intersections. It's going to cause 2 areas where the vertical line and the function touch each other, which again, you can't have that. You cannot have your x values repeat. So if I move the line here, so if I have like over 4 up 3, but I can also go over 4, down 1, and that causes me to have 2 x values at 4. And that's just an example. It's going to be that whole way, all the way through the figure. It's always going to be like that. So it's not a function. Anyway, so that's it for this one. Keep things moving. So here I got domain and range for equations. So we have equations here. So let's see, how can we do this? Now we haven't really covered graphing parabolas a whole lot. So some of these are parabolas, some of these will be lines, but that's not today's lesson. We're not going to be focusing on graphing stuff. So for this one here, I'm going to go over to the internet. So if you're watching this video, chances are very good that you have the internet. So I'm going to go ahead and go to Desmos, which is D-E-S-M-O-S. You can just type it into Google and go to graphing calculator. So there's a couple of different ones. Make sure you go to graphing calculator. And let's go ahead and plug these in. Let me get my packet here. So let's go ahead and graph that first one that's there. All right, so this way I don't have to keep switching back and forth between the different screens. Sometimes that can be confusing or disorienting to students. So I'm going to try to keep this going. Y equals negative x square. So we have a square. To type the square or any other exponent, well, mainly squares, you'd have to type exponents a little bit of a different way. But for square, that's pretty easy. So I have this variable square, so I just push that and it'll cause it to square. Now you notice our line has changed shape from a line to a parabola. And there we go. So the whole thing's graphed. We can see pretty much everything we need to. So if I go back, so starting from the low, what is the lowest number we can pick for the x value? So you can kind of see, yeah, so pretty much it goes to negative infinity, right? It's never going to end, and that's kind of the way these functions usually are. I know when you're looking at the packet, you're looking at that and thinking, oh well, it's going to end or begin there. But when you can see it in Desmos, it's like, okay, now you can see that it goes on for infinity. So we got our domain. It goes from negative infinity to positive infinity because this side also goes down to infinity. All right, and I don't want to be here all day just going down. So domain is all real numbers. Range, on the other hand, is a little bit different. So to calculate the range, we start with a line. And I'm going to go ahead and make a line that we're going to use. So kind of what I imagine, so when I'm kind of doing this with my hands, this is what you're supposed to be imagining, that I have a line that goes from the lowest number, which we already know is negative infinity, because these arms drop in both directions forever, until we reach a point where it reaches a maximum and we cannot go any further. It's just, that's the highest number we can go. If I wanted to get, like, say, 4 out of this, I can't. I cannot get 4 because my line, my function, the red one, does not go anywhere near 4. So there's no possible way I can get a 4 from this. The highest number I can get is 3. So our domain is any y value less than or equal to 3. Because again, down here, these are all the numbers less than 3. And is this a function? Well, I can go ahead and make my line here. And if I can go with the vertical line test, I can just move it here. And we already know that the bottom's kind of very similar to what you can already see, so it's not going to make a big difference. Or if I want to, I can also zoom out. And I can see that it's not going to touch any more than once. The red and the blue line should not touch more than once. And a lot of times with the vertical line test, you can just sort of you can just sort of imagine it in a way. Just imagine the line moving from one side to the other side, and that's usually going to be enough. All right, so okay, I'm going to go ahead and fill in these answers for our worksheet. So the domain, as we can see, goes sideways to all real numbers. The range, we knew that the top number was 3, so we can pick any y value less than or equal to 3. So I got a little or equal to because I can't type the or equal to button. And is it a function? In this case, it is, yes, it is a function. It is a function. All right, so let's go ahead and I'm going to switch on back to the other one. Now I'm going to go ahead and erase this and put in negative 5x minus 1. And we end up with another line graph. So these line graphs, again, they go up and to the left forever. And again, I could show you that. I mean, it also goes down and right forever. So we end up with this kind of line. Now, domain is all real numbers because side to side, it goes on forever. Even though it's really steep, okay, it's still going in both directions forever, not very fast, but it is. So I'm always going to get some number that I can get a value from and out of. Now, last question. Oh, sorry, the next one would be the domain, which is actually kind of the same thing because it goes up forever and it goes down forever. Since it goes up and down forever, then it's all real numbers again. And again, there's no holes or gaps in this line, which very rarely a function like a line will have a hole or a gap in it. It can happen, does happen, but it's just very, very rare. And your equation is not going to be simple like this one. It's not going to be the y equals mx plus b. It's going to look a little bit more complicated. Anyway, I'm going to go ahead and move my vertical line so that it's going from left to right. And again, I can zoom out a little bit if it helps. And we can see the intersection is just only crossing once. There's only one spot that it will cross, and it's going to be more the same down there. So I don't really need to go all the way to the side. So we should have all our questions answered. And again, that's a good thing about using Desmos is that you can pretty much see all of the things you need to work on at once. So domain in this case will be, let's see, all real numbers. Range is all real numbers. And it is indeed a function, so that's a yes. Okay, and these next two they're pretty easy actually, but I know students confuse these two all the time. So that's another reason why I would say go ahead and just use Desmos for graphing all of these things. And Desmos is a pretty useful tool because, you know, not everybody has the fancy calculator with all the buttons on it, which, oh, there it is, which would look something like this. But even if you had one, you probably wouldn't know how to use it because they're fairly complicated. To just enter an equation, you'd have a whole bunch of buttons to push, which you can do it. But honestly, even for like real life, if anybody ever needed something, you know, shoot, I've used Desmos a few times with completely personal things, you know, just it's very useful. And it's so easy because you just type things in. You don't have to worry about all these different buttons, and the resolution's much better as well. So like you can easily see, well, moving to our next one, we have y equals -7. Now, changing the window on this is pretty easy because you can just grab the screen and move up or down. And now I can see that my function is down here, the red line. And let's see. Now remember, I can only pick areas on the line. So I can pick 0, -7. What if I were to pick, say, 2, -7? What if I picked, say, 8? 8 and -7. All these y values are -7. I can pick any x value. I could pick 20. Sometimes it's a little bit tough, but remember, that's why it's continuous, because we can pick 20.02 or 19.94. So fine to adjust this. Sometimes it does get a little bit annoying when you're trying to pick something like 20. But if I pick x20, the y value is going to be -7. So actually the y is always going to be -7. So looking at it sideways, that line goes this way forever to infinity. If I go this way, it goes, see the line's still there, to negative for infinity. So that means the domain is all real numbers. What about the range? Well, in this case, range is very limited because we only have -7 no matter what I pick. If I pick any number from negative infinity to positive infinity, I'm always going to get -7. That's the only thing I can get out of this. Kind of like, I don't know, somebody who only says one word, they're only ever going to give you one answer. All right, so the last thing is, what kind of function is this? So is this a function or not a function? So I'm going to go ahead and grab my, oops, I have to go back down here a little bit. It's a little bit out of view in the window. So if I move my vertical line, it only crosses one time. And there's no crossing of 2 times ever. So easily enough, this is just, yes, it's a function. So let's go ahead and fill in the information that we just got done gathering. And I am going to put them here. So domain is all real numbers. And then the range, that one is a little bit different because y can only, I said y, can only equal -7. Which if you look at it, that's actually what the equation is as well, because there's only one thing we can ever get out of this, and that is -7. Is it a function? Well, it doesn't really look like it, but it is, because no x values repeat themselves. Well, let's look at this next one here. X equals -1. So again, these two are very simple. They're both linear functions, so they're both kind of in the y equals mx plus b form, but they're one of them is missing an x and the other is missing a y. So even though these are pretty easy, I get students that kind of mix these two up all the time. So let's just head on over to Desmos and see what it tells us. So let's go ahead and punch in our graph of x equals -1. Now you can see that I have my red line is completely vertical now. So if I want if I'm asking for an x value of 4, I can't get it. If I ask for an x value of 6, I cannot get anything. -2, nothing. So my domain is only, so look at my x value is only -1. That's the only thing I can pick. So domain is x equals -1. If I pick any number, like if I pick -2.88, it's still going to be -1. If I pick let me pick -7. My x value is going to be -1. It's always going to be the same. It's just not changing, never changing. And if I do the same going up, if I pick an a y value of 10, the only thing I can have for x is -1. But the range, on the other hand, so the x values goes up and up forever. I can pick x value like 44 or -100 or something like that. So domain is all real numbers. Okay, now time for the function test. Will it pass the vertical line test? So as I move my vertical line, nothing, but we have an intersection where it crosses more than once. In fact, it crosses an infinite number of times. So this one's not a function. All right, so again, remember the graph. In this case, x can only equal -1. It's the only thing we can get for x value. For range, going up and down, we can pick anything as long as it is a real number. Function, no. All right, there we go. And like I said, it's probably a better idea to use Desmos, especially, well, even if you knew how to graph it, you'd still have to draw the graph and get all this information from it. But again, we're going to be using Desmos for a long time throughout this course. It's a very useful tool, and again, it's gonna be useful quite a lot. Okay, so now we're gonna move on to kind of something else, and we're still on relations and functions, and I think normally this would be broken into 2 different lessons, but we're gonna go on to the next part, and I'm gonna try to cover this in the next 20 minutes. So tomorrow we're having a half a day, so I'm not sure if we're going to be able to cover this as well. So I'm going to just cram all this in here. We may not be able to get through all of it, but you just pretty much just need to do the parts we go over. And again, this is kind of a short thing on its own, so I don't really see a point in making this its own thing. And I really have no idea what the schedule is going to be like because they're also doing the vaccine thing and parent-teacher conferences this week. Anyway, function notation. So what is function notation? So we already know, I talked a little bit about lines, right? The y equals mx plus b. And we're just going to use that because by now in Algebra 2, you should be fairly familiar with it. So all you do is take out the y and replace it with f of x, is how you would say that, f of x. And that's it. Everything else stays the same. I noticed that there's a little negative here. That negative's not supposed to be there because it wasn't there before. But again, everything should be the same. The only thing that's different is that y has been replaced with f of x. So why would you want to do this? Why does y seem to work out okay enough? Why do we need f of x? So I kind of mentioned this a little bit before, that x is an input and y is an output. So think of a function like a machine, okay? And I'm trying to think of a machine that everyone would be familiar with and is not super difficult to get. Let's say a toaster. Okay, everyone's used a toaster at some point in their life. A toaster has a function that turns bread into toast. Right, you put your bread in there, you knock down the lever, and in about a minute, you should have crispy hot toast. That's its function. That's what it does. But in this case, we have our input, and the output, again, is toast. And anytime you think of a function, I know sometimes when people think of the word function, they think of something that's really complicated mathematical equations and stuff like that, which, yeah, it could be, okay? But function is just a very basic thing. There's an input and an output. Another example would be something like buying, well, I'm going to use this example because I just got done with it. And that is, let's say you're buying Pringles. All right, there is a price on this. And in this case, this one was $1.69. So there's the input. I go into the store and I say, well, I want 3 cans of Pringles. And if they're $1.69, that would mean it'd be about $5.07. That is the output, is the price. There, I tell them I want 3 cans of Pringles, and they tell me the price. That's I ask for 3 cans. That's the input. The output is the price. And the reason why you cannot have X values repeat themselves is because you should not get different results from the same input. Now, sometimes this might happen on a unusual fluke of some kind. But if I went into the store, and let's say I buy 3 cans of Pringles every week, so I know the price right off the top of my head. I could even bring the exact amount in change to the store when I go there. And one day I go in and it's not $5.07. Instead, it's $3.38. So what do you think the issue would be? I'm not getting charged the right price, and it's very, very rare that something costs less money when there's not a sale going on. So in this case, there's probably been an error. The cashier probably charged me for 2 of them when I wanted 3 of them. Or, they probably use that scanner thing and they probably thought they scanned all 3, but they only scanned 2 of them. I could probably walk out with a free 3rd can, but, maybe I wouldn't my conscience probably wouldn't let me do that. I'd probably still insist on paying. But you know that when something's wrong, when the price is not adding up immediately, that's kind of a sign that happens. So that's a function, because the more cans of Pringles I buy, the more it's going to cost. And you notice that something's wrong. Like if I bought 2 cans of Pringles and it turned up being $20, I would know something is wrong, because that's not how it works. Or if I went in one week and it was $5.08, and the next week I went in, it was $5.51. Okay, sometimes that happens, but usually when a price changes, it's very rare. Prices of Pringles usually don't change more than 4 times a year, but something like gas prices always change. So again, sometimes you can find examples where it doesn't work, because last week gas was like $2.97, and then next week it'll be $2.40 or $2.50 or something like that. It's just so hard to tell with gas prices. But actually the gas price is a function on itself as well, but because how much oil do you get? How much can you put through your refineries? How much oil is in one area? In 4 states, how much oil is there to split between all 4 of them? And they have to adjust the prices like that. So there is a function, but again, I'm just kind of giving you an idea of what it is. So function kind of means like what its purpose is and how it works. So that's why you cannot have 2 variables for x, or sorry, you cannot have 2 different numbers for x, because you just, anytime you do something, you're always going to get a different result. Anyway, so let's go ahead and move on to evaluating functions. So function notation is useful for finding a value in the range that corresponds to a certain domain value. Okay, that might sound kind of a little confusing. I wouldn't blame you. But here, they want us to evaluate a function. So they have this f of x. Now, f of x is like, well, it's like the basic function. Nothing's happened to it yet, but they want us to look at this next part, and they want us to put in -3. So what happens is I'm going to have to put -3 into the x value here. So I'm going to go ahead and just leave that blank. So instead of 2x plus 7, I'm going to put something like that there, so that way you can see that we have it. Now it's telling me to put in -3, so I'm going to go ahead and drop in a -3 right there. Now to evaluate it, I just need to start doing the regular math stuff to it. So 2 times -3 is -6. And the plus 7 is still there, so you'd use your normal order of operations. And let's see here, I'd have 1. And that would actually be the function notation. So if I'm going to write this as the answer, I need to put it as f of x, but f of -3. So the function at -3 equals 1. So this tells me that if my input is -3, then my output should be 1. So input -3, output is 1. So this machine, like a toaster, if I put in -3, I should get 1 out of it. All right, let's go ahead and practice this some more. So in this case here, what we're supposed to do is we're supposed to use this. So if it says f, we use this function. If it says g, we use this function. So let's try to get through this as quick as we can. I'm going to try to do maybe a few of these, and like I said, I might have to end up skipping a few of these, or maybe we can come back to this tomorrow or something like that. Maybe I'll post a video kind of going through all of them. Anyway, let's go ahead and do this one. So f of -9. So in this case here, we have f of -9 equals, and again, we got to use this function for f. So this is negative 5 times negative 9 minus 14. So there you go. I set it up using this function. I just replaced x with negative 9. And now I should be able to evaluate it. So 5 times 9 is 45 minus 14. And 45 minus 14 is 31. So I have been able to solve this entire thing. So f of negative 9 equals 31. So again, my input is negative 9. My output is 31. So again, this toaster says if I put in negative 9, I will get 31 out of it. Okay, maybe that doesn't make a whole lot of sense. Another example you could think of is maybe something like a microwave, right? So if you put something in a microwave, the longer it's in the microwave while the microwave is operating, the warmer it gets. So like for my microwave, it cooks cup noodles nicely in 2 minutes. Now, if I leave it on longer than that, it's probably gonna make some of the stuff evaporate, probably come out maybe burnt or something. But for most things, for most of the time, 2 minutes is perfect, comes out the right temperature. But what's never gonna happen is I'm not gonna put it in for 2 minutes and it's gonna come out ice cold, or it's never gonna come out on fire or anything like that. So in that case, it is a function. All right, so now I plugged it in. So I took g of 0.4 and I plugged in 0.4. So now I need to square it. Now I only have this cheap calculator, so I'm just gonna push 0.4 times 0.4 and I get 0.16. Plus, and here I have 9 times 0.4, which I know in this case 9 times 4 is 36. Put the decimal back in. So we had 1 decimal, so I'm going to put 1 decimal back in, so we get 3.6. And then let's see, plus 3.6. And then minus 1. So in this case, I should get 2.76. And this is just ordinary evaluation. I'm not doing anything different. I'm not doing anything special all that much. Just plugging these things in. Now, be careful with these, how you plug them in, because in this case here, there is negatives. So sometimes you might get negatives in there. In this case, I have to plug in -7. So I like to sometimes have these empty spaces where x used to be. So that way I know I'm putting in the right number. So -7 and -7. For this first one, it didn't make a whole lot of sense. Ooh, actually, you know what? Looking at it a little bit closer, I did miss something because there is supposed to be a negative here. So in this case here, this should be 2.44 because I was supposed to subtract that rather than add the 0.6. And I also did not put it into I did not put it in the proper notation because that's the whole purpose of this exercise is to put these in the proper notation. So f of 0.4 equals 2.44. Sorry, got a bit sidetracked there. Now, back to this part here. The reason I put this in the parentheses is because there is a negative that is supposed to be included. So it's -7 times -7, which would be positive 49. But there's a negative on the outside of that right here. This one is not affected. So even though the two negatives on the inside cancel out, -7 times -7 is positive 49, that outside negative is not affected. So once I get the parentheses off of it, it's just going to become 49. And 9 times -7 is -63 minus 1. And in this case, let's see. They're all negative, so my calculator cannot keep track of negatives, so I'm going to just add all of these up. So it looks like we get 113 or -113. So I think we're done with this one. Let's go ahead and put in g of -7 equals -113. So again, if my input is -7, my output will be -113. Okay, I got 1, 2, 3 more to go. 5. Ugh. I tried to get through as much as I could, but I think in this case, I might end up having to circle back for this. But I might as well at least finish this one here. All right, now with this one might look confusing, but it's actually not that bad. So we go back to function f. So in this case here, it's telling us f of 1. So f of 1, so -5x minus 14. But again, we're going to put in 1 in there. Now I'm going to do these two things separate. So the first one here we got is, let's see what we got. This is just the first one here. I'm not going to bother with the f of -4 just yet. And I get -19. Now for this one, I am going to use -4. So I'm going to do the exact same thing, but I'm going to plug in -4 instead of 1. And I should, well, let's see what we get. -5 times -4 is 20. And I get 20 minus 14, which is going to be 6. Now there is a negative here. So I need, in a way, -19 minus 6. And that's going to be -25. Oops, wrong button. So once I evaluate this, the answer is going to be -25. So some of these are not as difficult as they might look. So this one looks very confusing, but honestly, it's not so bad once you get started on it. So what we do is we evaluate at g of 12. So let's go ahead and get our g function, which in this case is -x squared. And then plus 9x minus 1. So it tells us to put in 12. So let's go ahead and put 12 in there. And again, this one has the negative on the outside. So even if I square it, I should get -144 plus 108 minus 1. And that's going to give us -37. Now hold on a minute. We're not done just yet because there's still this big 2 on the outside. And it's in brackets. But brackets are the same thing as parentheses. Like really, they're exactly the same thing. So what this means is that I'd have 2 times -37. And that would be pretty much the equivalent of -74. So -74 is this thing all the way complete. So I was talking about the half a day tomorrow. So with all my classes, I wasn't able to get, but you know, it's weird because I felt like I was going pretty quick, but somehow I just didn't get as far. With my other classes, at least I got to this slide here. But anyway, if you want to get the full lesson tomorrow, I'm going to go ahead and I'm going to have a class tomorrow. It is half a day because of parent-teacher conferences at the other schools. So because there's parent-teacher conferences at the other schools, they have to make time. So tomorrow's going to be half a day. So I'm not sure how I'm going to do the schedule, but what I'm going to do, well, let me tell you what I'm going to do. And that's it for today. So thank you for showing up. Thank you for being to the end. No, it's a little bit after the bell. You better hurry up and get to your next class now. Bye.
Oh, wait, I got a question. Are you still recording?